Yes, ma'am. Yes, yes.
Okay. আগৰ ক্লাছত আমি ডিছকাছ কৰিছিলোঁ তোমাৰ টাইপছ অফ ফাংচনেল ডিপেণ্ডেঞ্চি, ৰাইট? We have discussed about the types.
Yes, ma'am.
Some outside sound is coming actually. So today we are going to start this one, inference rules. Already that another video also uploaded, right? In the previous, in that video also I have explained. But still today it is live class, so again I'm going to explain this all. So inference rules, this is actually some basic rules developed by William Armstrongs. So these rules we can also call the axioms, Armstrong's axioms. Actually, these rules help us to find out the functional dependency, or determine the functional dependency from another one functional dependency, right? So there are so many, like not so many, 6 rules are there. Armstrong's help actually uh, explain or develop 6 rules for this functional dependency. By using that rules, we can easily find out the functional dependency, or the rules like we can derive from one functional dependency another one functional dependency, or we can find out from the relation how the functional dependency, which type of functional dependency is coming. Okay, so there are 6 types of inference rules are there. So reflexive rule and augmentation rule, like transitive rule, and the union rule, decomposition, and pseudo-transitive rules are there. Okay, first we discuss about the reflexive rule. So in reflexive rule, what happens is, say we are having the one set, and another one set is the subset of the previous set. Like if y is the subset of x, that means from x we can determine y. That means if x is the superset, that means, right? This symbol is actually superset symbol, right? X is the superset of y, that we can say y is the subset of x also, right? So here, if the y is the subset of x, then we can derive y from x, or we can determine y from x, right? So one example we'll take. So here you see x has the values, right? That means these are attributes A, B, C, D, E. And y is having the attributes A, B, C. So now you can see y is the subset of x, right? So A, B, C is here also, A, B, C. So this is the subset of, y is the subset of x, right? So in this case, what we can find out, so we can write like x determines y. By seeing this type of relation, you can say that this y, from y we can determine the y, sorry, x we can determine the y, from x we can determine y, right? So this is reflexive rule. The next rule is augmentation rule. So this is like partial dependency, you know, right? Okay, so here you see, say we are having x, and say on two like attributes we are having x and y. If the x determines y, then any other another one attribute which is added in both sides, that means both x and y, in that case also we can write like this: x z determines y z, right? For any z. So because z in both sides it is same, right? So x determines y, or you can say you can determine y from x already. So then you can write any z. That means z may be anything, but that z can be in add with x also and with y also. In that case you can write this one: if x is determining y, then you can write xz can also determine yz, right? So this is the augmentation rule. So here actually we are having the relation R, and in that relation we are having the attribute A, B, C, D. So if A determine B, then we can write AC determine BC, because here C in the both sides C is the same, right? In this case we can write like this: AC determine BC. So this kind of rules is called opposite. Okay. So now next rule is transitive. Transitive means like two relation are there. Like if X derives or determine Y and Y determines Z, then X can again determine Z. So in the transitive dependency, you already actually had that. In the transitive dependency also we find out like this only, right? So this is the same that transitive rule. So in transitive rule, what we have to actually find out, like if X determine Y, again Y is determining Z, then we can write this X determine Z. X determine Z. Okay. So that one example you can take that brothers, like if X is the brother of Y is the brother of Z, then we can say X is the brother of Z, like this. So next one is union rule. So in union rule, what happens, like if X is determined, like say X determines Y and X determines Z, so that both X can like determine X, Y and Z together also, like this. So if X can determine Y and Z, X can determine Z, then X can determine the union of both Y and Z, right? This is the union rule. That means both the function, both rules it is combining here, like union. Union means adding together. So X determine Y and X determine Z. That means you can then write X can determine Y and Z, YZ, which is called. Okay, now decomposition. Decomposition rules, it is the opposite of union rule, you can say. Say if X determines X and Z, then you can write X determine Z and X determine Y. So here you can see if X determine Y, Z, then you can write, that means you can decompose it, divide this one. X determine Y and X determine Z. Understood? Okay, this is the decomposition rule. That means union rule. In union rule, it is the opposite of decomposition. If these two are given, then you can write this one in the union. But in decomposition, it is there. From this, you can decompose that. Like X derives or X determines Y and X determines Z. If X is given like this, X determine Y, Z. Okay. Now, sixth rule is pseudo-transitive rule. So in this case, you are having X determines Y and YZ determines W. Then definitely XZ can also determine W, right? So in like transitive rule, like from these two, we can, the X determines Y, Y determines Z, means we can write X determine Z, right? So here it is pseudo-transitive. So here another one attribute is added, that is Z, right? So if with Z or Y, Z can add it, then with X also we can add it, and that can also determine W, right? So that's what here it is given. X determine Y and YZ determine W, then XZ can also determine W. In transitive, what happens actually? In transitive, if X determines Y and Y determines W, then we can write X determines W, right? That is our transitive rule. So in pseudo-transitive rule, if some values are added there, so with Y, say another one value Z is added. So like this, because Y is determined by X, X, right? So with X also, if we add something, that can also determine W. Understood? Okay, so that means X determine Y and YZ determine W, then XZ can also determine W. Because with Y, Z is added, that is determining W. So with X also, if we add the Z, then that can also determine W. Understood? Okay. Now this question, you have to answer that already in the assignment it is given. So if you all are listening, then you can, if any doubt is there, you can ask me. কিবা ডাউট আছে যদি তোমালোকে সুধিব পাৰা অন কৰি তোমালোকৰ স্পীকাৰ অন কৰি আছানে? Is there anyone? তোমালোকৰ কিবা ডাউট আছে যদি সুধিব পাৰা। Okay. Okay, কাৰ ডাউট আছে? Who is having?
No, ma'am.
If you have doubt in these rules, you can ask. At least one second, we can explain that. We can discuss that. Okay, if it is not there, then we can go to the next topic. Is there anyone like who is having doubt or something? No doubt, I think. So now I think some 1, 2, 3, 4, 5, 6, 7. So many students came, right? Okay. So no doubt maybe. So I can proceed to the next topic, right? Okay. So now we are coming to normalization part. Okay. So what is normalization? So normalization, that is the process, or you can say the methods that can help us or like to organize our database, the data in the database, right? So in our database, so many data are there now. How to organize that, the process or methods of organizing the data, that is actually normalization. So without normalization, your table or your data are very like sometimes same type of data you are maybe storing. Maybe you are repeating the like same columns, sometimes unnecessary data you are inserting. So without normalization, we may face like lots of problems actually in the database. So now in normalization, we can divide the like large table into small part. Like you are organizing that. Say if you are putting all the like data in one table, then it will be like, say for example, in our student database, a college, if we put all students, faculty, staff, library, like book information, everything, if we put in the same table, that will be very hectic to find out the like proper information when we want some like let's say information we want. That time it is very difficult to retrieve the data, right? Or sometimes maybe it's that same repetition may happen. Sometimes what happens, like insertion. So you are going to insert something, you have to insert some unnecessary like values also, repetition also comes. So that's why normalization is needed. If you normalize your table, then there are like proper, like there will be no any problem like insertion problem or deletion problem or updation problem. That problem will not occur, or there will be no redundancy also, right, if you normalize it. But without normalization in your table, there may be some redundancy, that is the repetition of data, you can say. So normalization is used to minimize the redundancy from a relation or the set of relation. That means from our table, we can reduce the redundancy. That means repetition of the data. So if the same data are repeating again and again, then what will happen? It will increase our size of the table, right? It will take more space in our database. It will take more memory, that means, right? So if the table size is increasing, repetition is more, that is unnecessarily repeating the same data. So we have to reduce that. For that purpose, we need the normalization, right? So relation means table, right? So relation or set of relations, that's our tables in the database. So like another one thing is we can use for eliminate the undesirable characteristics like insertion, deletion, and update anomalies. So anomalies means the like unexpected or you can abnormality, or like which we don't desire, we don't want that type of like values or something. So some problems. Anomalies means some problems, right? So we don't want that problems. To eliminate that type of problems, we need the normalization, right? So we'll discuss about this insertion, deletion, and updation anomalies. Anomalies, that is the problems actually, right? So we'll discuss about that. Okay. So here, say a normal for one example we'll take. So here we are having one student table. In this, we are having student roll number, student name, branch, HOD, office telephone number. See, all the tables are like HOD's information and office information also here itself in the same table. And students, like information also here. So now, if I insert the values here like this all, see, these values are repeating, right? Unnecessarily. CSC, Mr. X, this information branch information is repeating for all the CSE students, right? For all CSE students. So now you can see like this, if we are going to insert thousands or like hundreds students information in the same department, the same values are going to be repeated here, like branch, HOD, and telephone. These three columns will be going to repeat again and again. So this unnecessarily, it is repeating here and taking our space, right? And increasing our tables column, like tables, that one table is becoming bigger and bigger, right? Unnecessarily. So this is one kind of insert anomaly, you can say. So that type of problem comes, right? Again, here if we like delete some values, say the students are not here, so we are going to delete the students students details. Then what will happen? So if we delete all 404, 403, 402, 401, the last one if we delete, then we will miss our branch and HODs, that information also. That branch information also will miss it, right? So that is deletion anomaly actually. So unexpectedly if you don't want to delete that branch information, but still you have deleted the students like record, at that time it is also going to be deleted, right? Because it is in the same table. So you are going to delete the 4031, that roll number. Say we have deleted this all, and now last one also we are going to delete. Then definitely we will miss our this branch information also, right? HOD's name, office telephone number. These are also we are going to miss it. So that is deletion anomaly. And here, if you are going to say update the HOD, now HOD is changed. Instead of Mr. X, now Mr. Y or YZ, something, someone has come. So now you have to change the HOD's name. So now if it is not normalized, so now every column you have to, every row, in every row, this column you have to change, right? For all the students, you have to change the HOD's name. So sometimes you may miss some rows, right? For some student, you may miss it to change if it is not normalized, right? So this type of problems happens in the table if it is not normalized, right? That is this insertion, deletion, and updation or update anomalies, right? So this anomalies is that one, unusual, unexpected, or abnormality of the data actually. So now the types of like anomalies we are discussing. So already I have told you now, just now, right? Insert anomaly. What is insert anomaly? Insert anomaly again may happen like in the primary key and foreign key. So that I will discuss with. So three types of anomalies are there: insert, update, and deletion. Right? First one was insertion anomaly. That's what an insertion anomaly. What happens? Say you are having like two tables. In one table you are going to insert. Say in that table you are having one foreign key. In that, the foreign key. So that foreign key is primary key of another one table, right? So now, say we are having admission table and another one is student table. So in admission table, I am going to insert like students ID also. Say student ID is the foreign key in the admission table. So rest in student table, but the student ID is primary key. Now in this table it is like foreign key. So now if the student is not in student details, the student ID is not there, in the admission details you cannot insert it because the student's details is not all like ID is not there. So in the foreign key, and another one thing is foreign key cannot be null, right? So if you have to put otherwise some like other value, you cannot leave it null. It will not allow you if the value is not in the another one table. Say in the student table, if the student is not there, student ID is not there, in the admission table you cannot add the student ID as a foreign key, right? So that type of like problem is called like insertion anomaly, right? So and here you can see student and department. Now we have this department ID, the HOD and department name. So D1 is CSE and D2 is commerce. So in student details, we are having say D1, these are department ID. This is our foreign key here, and this is here primary key. Now D3 is not exist in the department, so this will not actually allowed. This D3 will not allow to insert here actually in the student table. That 404. In 404, the D3 department ID D3 that will not allow. Okay, that will not allow to insert because D3 is not exist in the department table as a primary key, right? This kind of problems, is anomalies are called insert anomalies, right? Or insertion anomaly. Now deletion anomaly, that's what I already explained just now. Say you are going to delete something, say here in this table is not normalized. So here if we are going to delete the record, unintentionally you are deleting this. So I'm going to delete the student record only, but unintentionally I'm going to delete the like branch or HOD's name also. Say 403 I'm going to delete, 402 I have deleted, 401 I have deleted. That means when I'm going to delete the last one, 401, I will lose all the branch, HOD and office telephone number also, right? So that is deletion anomaly. Okay, now update anomaly. That's what update anomaly already we have discussed. So if you are going to like update the value, say you, in the lots of value you are having, in that you are going to particularly going to update something here. Say in the example you can see say somewhere I may say instead of Mr. X I have now going to update Mr. Y. So by mistake I may again miss it, right? Mr. X, it is not changed. Other rows I have changed, but in this 403 I didn't because it is left. So this information is now wrong, right? Now in the updation time I have not changed this one. Mr. X, it remains him. So now if I take the information, so I will get the wrong information right now for this student 403. For the student 403, the HOD is Mr. X, but already HOD's name is changed. That means new HOD came. So it is wrong information, right? So this kind of problems are called update or updation anomalies, right? So now normalization, how the normalization will solve this all problem, that all anomalies. Now you can see this. So we are having this student details, right? In the student details, all this one table. Now we are going to, if we divide or like separate this table in two tables, student details and branch details, then how it can solve the problems you see. So now I have separated the branch details separate in the separate table and student details in another one table. So all the students record are here in student details, and branch details is in the branch details table. So now we are having CSC department, Mr. Y. Here you can see, instead of all four times, here only one row is enough, right? CSC department, Mr. Y, 5. This is insertion anomaly, you can see. Say here there is no repetition. The redundancy is not here, right? Now here in this side, so actually normal redundancy, normalization can reduce the redundancy or remove the redundancy. That means here redundancy is here, but it is reduced, right? Compared to this one in the student details, that first table, here reduce it, right? Only this branch column is repeating, because this is our primary key here, foreign key here. Here, say we are assuming this one as a primary key, right? So that is like insert anomaly. That is that, and it reduces the redundancy, right? By dividing this table in two tables. So here, how it will resolve the deletion anomaly? Let's see. Say I have to delete the students like 404, 403, 402, 401. If I want, I can delete every like students here. If I don't want the student details. But still, I will have this branch details, right? CSC, HOD, that Mr. Y, this information I will not going to lose, right? So that is how it is like resolving our solving our deletion anomaly, right? So now update anomalies, how it is solved. See, if some HOD is changed, our HOD is changed, instead of Y, we can write Z. Only one place, in this place, if we change, it will change for all the students. See, 401 CSC department. Now CSC department, who is the like HOD, Mr. Y, or if we change this Mr. Z, it will come. Okay. So here itself, whatever information is there, it is relating that, right? CSC department, just we have to go there, branch details, because it is pointing to this table, right? So that's how it is solving our anomalies. Okay. So this is the question actually already as an home assignment I have given. So now, if you all are there, you can ask your doubts. Are you there? Is there anyone? Okay. Doubt আছে যদি সুধিব পাৰা. Doubt নাই. Okay. So here your doubts, but in the last it will come, right? Today is 4th. I think no one is having any doubt or what. Okay, no one has typed actually. If you are having doubts, who are all listening, I think you can type. Otherwise, you can directly ask also by doing microphone. If you have doubt, you can ask. Okay, otherwise, we'll move to the second topic. That means next topic. If slide to দেখা নাই কৈছে ন? Okay. Oh, June 1. But today's it is not coming. 6. Oh, first. Today's 4th, but for June, no one has typed, I think. Only this one is no doubts, ma'am. Only one. I did no doubts. Okay. Sankhana. No, that's okay. Then we'll move to the next next topic. Okay. Now, types of normal form. Okay, normalization we have talked about, right? So now that normalization process that can be divided into different forms, which we call normal forms, right? That normal forms may be first normal form, first NF, second normal form, second NF, third normal form, 3NF, or third NF, Boy's code normal form, BCNF, fourth normal form, 4NF, and fifth normal form, sixth normal form. Okay. So now, see just one like overall view. I just want to show you here. So we are having in the first, we are having our table. Like in that table, we are not normalized. Okay, that table we didn't normalize. The simply we are having that table now. Unnormalized form, that is. So transfer the attribute into table format. So you are having the attributes and all that you first you have to make it in the table format. So now you got your table. Now if it is not in the normal or first normal form, what you have to do in the first normal form, there will be no repetition. So in your attribute, the attribute value cannot be repeated. That means multiple value it will not allow. Like in one column must have only one value only. So sometimes we are having like 2-3 mobile number, but we in that value we are having say we cannot write 2 mobile number at the same column in the same row. Okay. If it is not like that, if the repetition is not there, then it will be in the first normal form. That means if you remove the repeating group, then it will come to the first normal form. Okay, in the first normal form, there should not be any repetition of the attributes value, or multiple values will not allowed actually here. Then if you remove the partial dependency, then it will come to the second normal form. So partial dependency already you know, right? What is partial dependency? We have discussed already. Then if you remove the transitive dependency, then it will come to the third normal form. See, if it is in third normal form, then it should have in the first and second also. That means in the if you are in the second normal form, that means that should be first in the first normal form. Then you remove the partial dependency, then it will come to the second normal form. And in the third normal form, it should must be in the first and second. Then if you remove the transitive dependency, then it will come to the third normal form. Like this, in BCNF, make sure if every okay determines the candidate key here. If we determine the candidate key, that means candidate key, you know, primary key, candidate key. Okay, that we will discuss here again. How it actually it is candidate key, you can find out. We have to remove that. Then multi-valued dependency, that if you are having multiple values, the multiple valued dependency, then you have to remove that. Then it will come to the fourth normal form. Remove joint dependency, then it will come to the fifth normal form. Then database contains no constraints, that means there will be no restriction anything. Then it will come to the sixth normal form. Okay, so this also like same only. Here only fifth till fifth it is there. So we will get our data source like this only first time. Then you have to transfer it to the table format, remove the repetition, then remove the partial dependency, then remove the transitive dependency, then determine the candidate key, then remove the multi-value dependency, then remove the joint dependency. Then sixth one is that if there is no constraint, right? Okay, so now we'll discuss about the first normal form. So now first normal form, that value should be atomic.
ম্যাম স্লাইড তো দেখাবো নাই ম্যাম
Slide দেখাবো না, no?
নাই ম্যাম
Oh, you can see. Okay, okay. How many of you didn't see the slides actually? Now is it visible?
নো ম্যাম
So,
নো
visible.
Others, maybe then others are, if others are seeing this, then maybe it is only his problem, connectivity problem maybe. দেখিছা নে এতিয়া নাই দেখা?
নাই দেখা মেম, নাই দেখা।
How about
বাকীবিলাকে দেখিছা?
পাইছো।
Okay.
মেম ৰ'ব,
Okay.
ডিছকানেক্ট কৰি আকৌ জইন কৰো।
ঠিক আছে, তুমি জইন কৰা। Okay, so we were in the first normal form. আমি এতিয়া এইটো ফাৰ্ষ্ট নৰ্মেল ফৰ্মটো ডিছকাছ কৰিছিলোঁ, হয় নাই? তো ফাৰ্ষ্ট নৰ্মেল ফৰ্মত হ'বলৈ হ'লে তোমাৰ কি হ'ব? প্ৰথমতে ভেলুবিলাক এটমিক হ'ব লাগিব। তাৰমানে একেটা কলমত এটা ৰ'তে মানে আমি দুটা বা এটাতকৈ বেছি ভেলু এণ্ট্ৰি কৰিব নোৱাৰিম। There should not be more than one value in one like column in the one row. That means there is each like attribute contains only atomic value. That means only one value they can hold or they can contain, right? So here you can see the example. We are having this employee table. Okay, employee table we are having. In this you can see in the employee phone number. So 2 phone number it is given, right? 2 phone number it is given. This is multi-valued right now. So this is not allowed actually. So now this is not in the first normal form. This table is not in the first normal form. If we remove this one, we make another one row for this one, for this like say mobile number. Here 2 mobile numbers is given, right, in the same row. In the same row, employee mobile number one is 7272826385. Another one is this one. So now this table is having multiple value, right? So multi-valued is there in this attribute. So employee phone phone in this attribute multiple values are there. So this is not in the first normal form. The table, if it is in the first normal form, then it should contain only atomic value. That means only one value it can hold. Each attribute can hold only one value. That means like atomic value only it can hold. So say now to become to make it in the first normal form or put it in the first normal form, what we have to do? We have to divide this ones. For example, see now for the employee phone number, what we have done? We have inserted this again, right? We have separated these values. So employee ID, for here employee ID is same, name is same, state also same, but he is having different phone number. So now again we have inserted. Now it is in the first normal. This table is now in the first normal form. Okay, so here you can see there is no multi-valued attribute. Each attribute is having only one value, right? See, the repetition is there. It doesn't matter in the first normal form, because in the first normal form our main property is each attribute, the attribute cannot hold multi-value. That means the attribute can have only one value. So that property it is now satisfying that property, right? So now this is in the first normal form. Okay, now second normal form we are coming. So now what will happen in the second normal form? To be in the second normal form, it must be in the first normal form. The first normal form, and that should be that means it should not have multi-value. So in the second normal form, all non-key attributes are fully functional dependent on the primary key. That means functional dependent. So and fully functional dependent, that we have discussed in the previous classes, right? Fully functional dependent, what is that? And non-key key attributes are like primary key, right? So non-key attributes are other which are not primary key. So now example we will take here. So let's assume a school can store the data of teachers and the subject they teach. So here we are having teacher's ID and subject and teacher's age. So now teacher ID teacher ID can determine subject, right? And teacher ID can also determine teacher's age. So now here you can see if this one is in the first normal form. Now whether it is second normal form or not. It is not in the second normal form because here we actually this from this one again we can separate these two. Say teacher ID, subject, teacher ID and age, because it is repetition is coming independent, right? So now if we divide this table like this, wait, next see here. So teacher ID can also determine that teacher age, right? So that's why if we divide this that table into these two tables, then it will be in the second normal form. Are you getting? Okay, see here. So teacher ID 25, age is 30, 47 is having 35, 83 is having 38. Subjects, we are having the subjects like chemistry, biology, English, maths, computer. So same teacher can teach different subjects. Like 25 teacher ID. So he's taking two classes, two subjects like chemistry, biology, and for 83 it is like maths, computer. So now we have separated this one. See, fully functional. It is here. It is not fully functional dependent. It is partial. You can see here. Teacher age. If we are going to determine, only this can also see. Teacher ID can also determine the teacher's age, right? So, but here we are having teacher ID subject. Then again, teacher age is there. So this in this table it is not in the second normal form. But if we divide this one here, see it is this one fully functional dependent, right? Teacher age is fully functional dependent on teacher's ID. So teacher ID determines teacher age. Teacher ID determines the subject also, right? So now another one example for this I'll take. Then maybe you will understand this. Say we are having this student relation. In the student relation we are having ID ST, that is student ID, this one student, then professor ID, then professor's name, then grade. Like in this case, see the full functional dependencies are there. Here. This function, there are three functional dependencies you can find out here. So attribute professor name is functionally dependent on attribute ID professor, then professor ID. Professor ID determines professor's name. Here you can see professor ID can determine professor name, and student ID is determining the student name. But for the grade, both student ID and professor ID is determining the grade. We need both this one. These two are not needed for the grade. Only ID of student and professor ID is needed for that. Here, if we divide this table in three different tables, after normalization, you can see here. So student name and student ID. Here, student ID 1, 2, 3, and this other student name. Professor ID 3, 2, 1, and professor name are this. So now grade, for the grade we need only the IDs, student ID and professor ID. Then for professor ID 3, student ID 1, which that student is having student ID 1, that means Molly, and professor ID 3, that means Didi. What is the grade for that? Is having the grade 5, right? So now in this table you see there is this repetition is not there here. So here only ID, student ID and professor ID, then grade. Only these two are needed for this to determine the grade. So now this is fully functional dependent. You can see here only professor ID cannot find out the grade. Only professor ID is not finding. Only professor ID is not finding the grade, and only student ID cannot again find out the grade. Like See, only one student. Say, if I take student ID 1, so see, if it is a professor ID is not given, then which grade I will choose? Like student ID, which subject I will choose? So it may be for professor ID 3, 2, or 1. Which one I will choose? So here it is properly given, right? Student ID 1 for the subject, like professor ID 3, the grade is 5, right? So this is fully functional dependent here, all right? So this table is now in second normal form. Understood? So now first normal form is there should not be any multi-valued attribute. And second normal form, it should be first in the first normal form, then the fully functional dependency, that non key is there here. See, the fully functional dependency should be there here. Okay. So these are the first normal form and second normal form. Then third normal form, we are coming to the third normal form. Okay, before going to third normal form, first and second normal form, are you clear for these two? I want to go and see the doubts is okay, second normal form, are you clear? Is there any doubt? No doubts, I think. You can unmute and you can talk, no problem. No doubts? I don't know whether students are listening or just join and went somewhere and doing their own work. কানেক্ট কৰি পেলাই চব গ'লগে নেকি ক'বাত ফুৰিব চুৰিব?
মাজতে দেখাই পোৱা নাই।
দেখা পোৱা নাই ন? এতিয়া দেখা পাইছা? অ'কে। ছেকেণ্ড নৰ্মেল ফৰ্মত তোমাৰ আমি কি পাৰ্চিয়েল ডিপেণ্ডেঞ্চিটো তোমাৰ আঁতৰাই দিওঁ, হয় নাই? ফাৰ্ষ্ট নৰ্মেল ফৰ্ম আৰু ছেকেণ্ড নৰ্মেল ফৰ্ম এইটো মনত মানে এতিয়াতো বুজি পাইছা? হিয়াৰ কি কৈছে জানো? অ'কে, নো ডাউটছ বুলি আহিছে। তো এতিয়া তোমালোকক যদি কুৱেশ্যন সুধো বা তোমালোকে নিজে কৰিব পাৰিবানে? এটা টেবুল যদি মই দিওঁ ছেকেণ্ড নৰ্মেল ফৰ্মলৈ টেবুল এটা দি দিলোঁ, ছেকেণ্ড নৰ্মেল ফৰ্মত আছেনে নাই দেখাব পাৰিবনে? You can type your query. Or your, like, if you want, you can type whether you can do it or not. Yes, ma'am, only one student. Okay. So today's class, I'll stop now here itself, because third and others I will discuss in the next class. Yes, I have some more. I have to leave little early. Okay. So if you are having any doubt, you can write here, or otherwise you can message me, no problem. Okay, today's class I'll leave now itself. Next class I am having, I think, in the Monday. And otherwise, you just note down that students' attendance who are all present. I can see this already. I have noted it down, but still you write it and send me. Okay. Almost how many? Just I go through it. Okay. Okay, then stay home and stay safe.